I don't know. Okay. Okay, guys. Today we have special guest. It's a rising star of agriculture tech space, one of the most brilliant minds behind that new market. And today we will have very deep discussion regarding the products and overall opportunities related to the agricultural robotics, and that will be very deep and interesting conversation with my partner Chinmay Soman. Is it right? I hope it's right. Yes.
Hey, Aaron. Yeah, great to be here, and great to get have some interesting discussion and figure out a path forward so that we can make this world a better place.
Thank you. Honestly, I do realize that you are way more than just words about making the world a better place, because you actually creating the solutions, and that solutions, it's not like concepts, it's like easy, understandable, and very efficient way to, let's say, improve our agriculture space and the world in general. We will talk about that right now. But the question is, how did you come to agriculture tech? How did you come to that market, and what inspires you the most in that fast-growing technology sector?
Yeah, no, that's a really good question. That's a great place to start. So both me and my co-founder at EarthSense, Girish Chaudhary, we grew up in India. We've actually been friends since we were 10 years old, so high school friends. And a lot of my family is involved in agriculture, small farmers in India, my wife's family, Girish's family. And we were also very environmentally minded, in terms of sustainability and things like that. After college, after getting a degree in engineering, material science, I did research on nanobiotechnology for cancer diagnostics, cancer therapeutics, so very different from agriculture. But as I was finishing up, it was becoming increasingly clear that agricultural sustainability, environmental degradation, these were some of the biggest threats to our whole civilization, to the planet, honestly. So I started thinking about how I could, help make the planet, help heal the planet, but at the same time, also help farmers all around the world, especially farmers in Asia, Sub-Saharan Africa, South America, all of these places where the conventional agricultural technology hasn't really served them. Girish and I started talking about how emerging technologies of AI, robotics, machine learning were going to help farmers. And honestly, we just started going out and talking to farmers in India, farmers in South America, farmers in the US as well. And one of the things that we figured out was that conventional agricultural equipment, the large tractors and planters and harvesters, they're very, very good, right? They're very good at doing what they do, but they're solving a very specific problem, which is how to do agriculture with the fewest possible people. So there's always one person in charge of operating the machine. And that bottleneck, that sort of, drives a lot of those decisions of like, okay, we need to have a massive, expensive, machine that costs hundreds of thousands of dollars, guzzles, tons and tons of diesel, compacts the soil, destroys the soil, in order to do just massive monocultures, right? Like trillions of just corn and soybean plants. And that's no way to run a good agricultural system. What we realized that when you really focus on autonomy, like actually fully autonomous equipment, then you can get rid of this constraint of like, okay, how can I get one person to do the maximum work and make this bigger and bigger machines? Instead, you can go the other way, and you can make smaller and smaller and more intelligent machines that can actually deal with the complex ecosystems that nature would like to create, right? I mean, that's what current agriculture is. We try to remove complexity from agriculture, make it as unnatural as possible. And that's why we get all the bad effects for, like, we make lots of calories, of course, but at the cost of everything else. So that was the key insight, to say, okay, yes, we need to help farmers. We need to change the way we do agriculture, because the way we do agriculture is destroying the whole planet. And the solution to that is creating these small autonomous machines that actually enable us to create and manage naturally inspired ecosystems. These are not going to be obviously like completely natural ecosystems. They're still going to be shaped to our needs, but they're much more self-sustaining, regenerative, climate resilient, and climate change fighting systems.
Very advanced mindset. It's so let's say honestly, it's way deeper than I could expect. From the discussion, it's actual understanding of the whole ecosystem, and it feels like it's not like a robotics for itself, for the sake itself. It's like you actually need it. You just reverse engineered the whole things around the problem, and you created that solution that actually needs that robotics, and
Exactly.
that's very beautiful. Okay, what are the key functions of your robots, and how did AI come to agriculture? Because I do realize you have that machine vision background back in the days working with that cancer cells. So that machine vision background could help you a lot creating that advanced AI for your robots. But could you explain more and what's the key functions of your robots right now?
Yeah, absolutely. So we can, keep the focus on dealing with complex ecosystems, right? So if you want to do that, what do you need to do? You need a system that on board has enough intelligence to understand the differences between different plants, different parts of each plant, and then is able to do the useful, necessary things at different points in the plant's life cycle. So it needs to have various ways of harvesting or managing or controlling some of the undesirable species of plants, what you would call weeds normally, all of those kinds of things. So machine vision is a key component. Doing that on board a small robot that has very limited battery power and limited computational power is still a cutting edge problem. So that's what we currently do. And then the way we saw the path to this was kind of like, if you've heard of the Tesla secret master plan, right? So in the early days of electric cars, there were two main events that happened. The General Motors tried to do the mass market EV1, and they just miserably failed because the performance of that car was very, very bad. And they tried to sell it or lease it to the mass market consumer, right? So that's a very bad mismatch between an emerging technology and who you market it to. Whereas what Elon did very smartly was that he said, yeah, this car is going to suck, but we should find who is still willing to pay top dollar for it, right? So that's why they developed the Roadster, sold it to all the rich Hollywood celebrities, and then continued to work on the technology, bring down the cost, bring up the production capabilities. And of course, the objective is to have these large mass market for the electric cars. And that's now, we see that happening. So we followed, we discovered in parallel the same strategy that like, okay, yeah, this technology is not going to be ready. When we started back in 2016, 17, we knew immediately that this technology, if we tried to sell it to farmers, we're going to lose their trust because it's not going to do what they need it to do. So we identified early adopters in our market, which is basically scientists who want the highest quality data from their fields. And we started working on that. So autonomous collection of data and machine vision based analysis to tell them exactly what's going on with those plants. And that now that we have that, sensing and autonomy, sensing and actuation, now we're starting to do large scale cover crop planting for carbon sequestration, large scale precision fertilizer application. All of those applications are starting to build up as we create sort of these ecosystem of robots, family of robots that each are specialized in doing different things. And then together, they're capable of managing large-scale, productive, sustainable ecosystems.
But truly very deep, like, and your business approach, your, let's say, your overall strategy, the way you approach those niches, it's like a lot of respect with every ideas of yours coming. Let's say, okay. The idea is, the question is it possible for the terrestrial data to be aggregated and mutually enriched by satellite data? Do you have any ideas how your, let's say, infrastructure, your, let's say, agile, flexible infrastructure could work together with that satellite data and anything that's already exists on that market? So how that those big data could be, let's say, cooperate and work together?
Yep. Well, that's a very important point. We always think about what already exists out in the marketplace that we can integrate with. So satellite data or other kinds of agricultural data is one of the key things that we're integrating with. So we're working with several partners on figuring out how their data and the insights that they derive from their data, what that's useful for, and then how our really high resolution, really highly specific, actionable, timely data that we get from our ground robots that can supplement and enrich, like together, that whole data set is far richer and far more capable.
Yes, and even I'm mostly asking regarding that live data, because it feels like yes, that you could enrich and, let's say, could help, let's say, to make all the satellites data more precise, because you could help that satellites to be more current, and that's, you could even could coordinate those satellites during that process, and that's the most beautiful thing about that, let's say, cooperation. Do you have that type of ideas? Do you think you could, let's say, somehow to be connected with those satellites and not just merging the data afterwards, or even merging the data in real time, but actually navigate them somehow, so helping them to be more precise? Because
absolutely. Yeah, so there are several ideas that we're working on that we'll do in the next several months, actually, including, so one of the sort of points of complementarity is resolution, right? So satellite data, each pixel is several thousand plants typically, right?
Yes.
And by the time you see that a few groups of pixels, a group of pixels has started deviating from other pixels around it, it's usually too late to do anything about it. Whereas our data with the robots going along the plants and like scanning every single plant, that generates much more timely and actionable insights. But obviously, we're not thinking of building billions and billions of robots, right? We want to sort of, make the least number of robots that achieve the maximum amount of impact. And the question is, what is the complementarity between sort of daily satellite passes versus, the robots going through the fields, once a week or something like that, right? There are also times when satellites can't see the ground at all because of cloud cover and things like that, when the satellite can say, hey, I can see, but this is a critical time period, you should send more robots in and monitor this area more intensively in order to fill in those gaps. So there's a number of those things that we're working on with potential partners, and we're always looking for more partners as well.
Yes, we have very big friends of like Noosphere Ventures. They actually have the satellites, and it feels like I should introduce you to those whales, because it feels like you doing something very, let's say, complementary to what they have for the moment, and that's that's like could be perfect match. I do realize how much effort you put in building all of that. It's truly incredible. What I'm trying move forward, but it was a question regarding what new business niches and directions will appear in the next decade regarding synthesis of all of that connected devices and also advanced satellite data and in that agricultural field. Could you, let's say, show us the near future of your industry? What's the most important things to look at?
Yeah, absolutely. So one of the most interesting thing that's happening is with this kind of data and with this kinds of like new actions that are possible, new types of management practices that are possible, we can actually make new commodities, right? So carbon, for example, large-scale carbon sequestration, global agricultural soils can sequester 1 billion tons of carbon every year. If we do the right management practices, such as planting cover crops and doing no-till agriculture and things like that. So AgTech, our technology will enable sequestration of more carbon, and then in combination with satellite data as well as our data on the ground, we can actually validate that hey, half a ton, 1 ton of carbon was sequestered on this particular acre, and then build a carbon credit, put it on the blockchain and say, hey, yeah, this is data, this is carbon credits that you can trust. And large companies or even individual customers that want to offset their carbon emissions can buy that carbon credit and say, hey, yeah, I'm offsetting my own carbon emissions. And by the way, in that process, I'm making the agricultural system more resilient to climate change, more productive, more, generating better food. And then, so that's the other part. The food itself that comes off of these regenerated landscapes, that's more nutritious, that's more, healthy for people to eat. So there's potential for charging more for that kind of food. So farmers benefit from it because they get more income, and then of course consumers benefit from it because they get better food.
And they could prove it because of
yes.
your the idea of proof of
traceability.
Eco food growing practices. It's just important because nobody trusts right now in all of that eco labels. It's like we know that eco labels sometimes represents very strange things, like very small fraction of the whole process. Building around destroying everything on every step, but just on that small miracle when it's like somehow could be treated like eco, it's put as a label on that product and shipped, and the people sometimes paying let's say twice as more as a regular thing. So it's very important to know what's going on with my food, with my coffee, with my chocolate beans. I'm actually willing to know that if I could scan that just QR code and try, and maybe sometimes look at what's going on right now at the field. Let's say look through that eyes for the moment, or some pre-recorded live.
See the whole history of how that coffee bean came to you, right? How that cup of coffee was made.
I mean, actual visible, proven. And yes, definitely should use the blockchain for that, because if it's a question of immutability. It's a question of ability to prove that that photo or that, let's say, video made at the present, at that date, at that place. It's like a very important way to, let's say, create that transparency during that.
That's exactly right.
Food supply process. But how do you perceive the issue of preserving our planet and biodiversity beyond carbon credits? So what's beyond carbon credits we could do for preserve biodiversity on that planet?
Yeah, that's a really good question. So it comes back to the ability of these advanced autonomous machines to actually deal with that complexity, right? The reason we've been reducing biodiversity is we don't know how to have productive agricultural landscapes that are highly diverse, other than maybe like really putting a lot of people back to work on the farms. And I don't think we should do this, right? Like as rewarding as gardening might be, or small scale farming might be, it's a hard job. I think most people don't want to do it. And at the end of the day, it's not not something that moves civilization forward. It's a maintenance industry at the end of the day, right? We have to produce food in order to live. We obviously enjoy eating good food, but in order to create it in a way that's highly sort of planet friendly, that requires a lot of intelligence for planning and managing and harvesting from these complex ecosystems. But at the end of the day, it's the same work year after year, every year, right? And people that enjoy it should do it. But should we go back to the days where 40% or 60% of the human civilization was working every day on the farms? I don't think so. I think people can do far more creative things. So I think the way to do that is imbue the necessary intelligence for those kinds of tasks into these next generation autonomous machines, so that they can be our hands and eyes on the field. And yeah, we can drop in whenever we want, or we can from in an AR type system or VR type system, we can see how our robots are doing, help them out as necessary, and over time create these complex ecosystems that are regenerating, that are actually claiming back some of the degraded and desertified lands. And in addition to sequestering carbon, of course, we create these biodiverse systems that purify our water, improve air quality, reduce soil erosion, all of these kinds of other ecosystem benefits, some of which may be also financialized in terms of ecosystem services credits. That's certainly possible as well. But some of this will just have intangible outcomes, or tangible outcomes in terms of greater production. So 40% of the world's land area is arid or semi-arid. A lot of that has changed in the last 100, 200 years, when we have caused those areas to become unproductive, where we can take back that land and make it more productive, make more better food for the 10 billion people that are soon going to be on the planet.
Very beautiful approach. Regarding that advanced ability to, let's say, you have a swarm intelligence, basically. It's more, or even more than swarm intelligence with your, let's say, robotics and your solution. How that swarm intelligence could be actually working together with, let's say, our Earth as like the big superorganism, like could you let's say help us to understand that advanced meta engineering of, let's say, collaboration of swarm of that intelligent robots and the Earth itself as a whole, as a superorganism, how it should look like from your perspective?
That's a really good sort of deep ecological and almost philosophical question, right? So if we do a thought experiment, let's say somehow today all human beings vanish from the planet, what happens, right? We stop messing with the planetary ecosystem, and over time, maybe in 100 or 200 years, the planet regenerates, and it's a healthy, dynamic ecosystem, highly productive, sustainable ecosystem. That happens. Obviously, we don't want to do that, right? We're not Thanos. We want to enable these next generation robots to actually help the planet do what it would naturally do anyway. We just want to help it do that faster. So instead of having 50 or 100 years, we want to help it create these balanced, productive ecosystems in 5 years. And because we don't want to put like 2 or 3 billion people back to work on the farm, we want to do it with robots. So that's the key role of this advanced technology. It's not that it has to brute force it. the planet wants to do this. The ecosystems, the biological organisms that exist on the planet want to do this anyway. We want to be the catalyst that helps it tip over from this downward spiral that we're in into a positive regenerative trajectory. So that's kind of our view of what the role of our robots is. Again, not to make billions and billions of robots, but make the fewest possible robots that can transform billions and billions of acres into productive, balanced, biodiverse ecosystems.
You have very clear vision, and that's also, let's say, it's you could structure even so that's complicated question to very, very precise, let's say, very step-by-step actionable strategy. So yes, it's truly interesting. Okay, we have that question. What efforts, in your opinion, could large agriculture producers to take to preserve biosphere? So what efforts should they, let's say, do to, let's say, help you with your mission, help you with the project you just, let's say, picture?
Yeah, so we're always looking for partners, farmers specifically, who are interested in improving the land. And that has direct benefits to farmers themselves, right? So improving the soil quality through fairly simple things like planting cover crops, enriches the soil, increases its nutrient density, helps the soil hold more water. So your farm becomes more drought resilient and climate change resilient. It helps it actually, capture more water when there is extreme rainfall events. So instead of the rainfall washing away your soil, you actually preserve the soil and combine it with, keep it on your land. So all of these kinds of, so that's how we're starting. What is the simplest thing we can do that benefits farmers and that benefits the planet? So planting cover crops is one of the big things we're starting with. And then these kinds of polyculture, ecosystem approaches too, right? So planting cover crops is one type of polyculture. You have, your main crop at, 3 or 4 months during the year. And then for the rest 8 months, you have a, complex mix of soil enriching species planted. So that's one type of polyculture. But another type of polyculture that we hope to go towards is where you mix, trees and shrubs and grasses all together and have a mix of equipment, autonomous as well as semi-autonomous, and people helping transition that to a productive ecosystem. So we're always looking for partners who are interested in doing projects like that, and who want to grow with us and who want to give us valuable feedback on sort of specific types of agricultural autonomous robots we can build.
It feels like that your project should be backed by, let's say, some big government institutions, because it's important actually, because what the nation itself it is, what the nation itself it is, what the country itself it is. It's a land. It's a land, and the way how you manage that land, it's your direct responsibility as a government agency. Nobody, I don't know, maybe somebody is looking at that question like that, but it's very important to be sure that the land of that country is actually protected, and actually you have some sort of guideline. But the most immortal, the most treacherous thing of yours, actually manage in a good manner. It's because it feels like you should be backed by big government institutions, because it's their direct interest, it's their direct responsibility to, let's say, protect the actual asset, the most important asset they have.
That's exactly right. I think, as you probably know, Franklin D. Roosevelt, U.S. president back in the early 20th century, he said, "The nation that destroys its soil destroys itself." Right.
Yes.
So that's one of the primary responsibilities of a civilization, to take care of and improve its soil. And because if you lose your soil, you don't have anything. So yeah, I think if there's anybody amongst the audience that wants to figure out how we can work with large, national or state government, we'd love to explore those opportunities. In some ways, one of the things that we're doing these days is figuring out how we can work with large landowners. And these are often very large scale institutional investors that own large pieces of land, like thousands of acres, hundreds of thousands of acres, as an asset class. And for them, it's directly in their interest to improve the productivity of their land and improve the value of their asset itself. But yes, ultimately, the largest landowners are often nation states.
Next question will be like slightly easier, but let's do it. How will your robots reduce the amount of pesticides and herbicides in a food, making it cheaper and healthier? That's
yeah. Oh, and that's one of the huge underappreciated threat to our global food system. So that last 30, 40 years or so, we've been increasingly using herbicides to control weeds. That's what most of the GMO plants are, corn and soybean especially. But as happens every time you try to fight evolution is going to win, right? So weeds are becoming increasingly resistant. So just like we have antibiotic resistant bacteria, we have herbicide resistant superweeds that are that just cannot be killed by any chemicals now. And one of the main things that we're working on is how we can train our robots to distinguish between desirable plants that we want in our ecosystem and undesirable plants that are harmful to our ecosystem. And then then it becomes a lot easier for the robots to pull out the plants that we don't want on that land. So that's a clear objective. From a pesticide and fungicide perspective, again, it's a similar problem. What we currently do, because we don't have enough people doing farming, is that we spray the whole field at a fairly high dose, just to have insurance against a potential future infection, potential future insect infection.
And that's could be way more interesting assets than the carbon credits itself. It could be, let's say, it could be like tokenized, let's say, it's also could be tokenized, like insurance. It's like insurance policy
reduction.
Yes, and you could, let's say, because we're already going to selling the land, or like tokenized land or something like that, and you could be some sort of it's like a multiplier, because it's not just soil, it's not just the land, it's not just the soil, it's a productive soil with some sort of insurance against, let's say, biggest issues you could get with that soil. Then sometimes it could be even predictive, let's say, results, like if you buy that soil or rent that land for, let's say, for a decade, that you could grow based on your data and maybe insured data, and let's say somehow, let's say you could invest very, very wisely and in that land, and that ability of to structure that investments, it's like it could be even paramount of what you do right now, because it's a beautiful, very beautiful financial vehicle. If you could, let's say, enrich that land with all the data and all the understanding of the actual value, and it's like
absolutely. I think that's a key part of the sort of future of these technologies, where or key application, where you can take a piece of degraded, low value land, and through these regenerative practices, as well as keeping accurate track through ledger technologies of all the improvements that we are making, of all the benefits that land starts generating, then improve the value of that asset. And then, yeah, that can be the sort of, fractional ownership even of that asset can be an interesting vehicle for people to be able to invest and back these kinds of efforts.
Okay, the next question also will be deep. It's a question regarding the true responsibility at all stages of food production. I mean, by responsibility, I mean following bioethics on the molecular level of all production and products life cycle phases. So this, while taking into account destructive influence on the biosphere. So what if, just what if, because we have a lot of things related to logistics, a lot of things related to the production of our food. What is it actually possible with all that advanced robotics, maybe not just yours, but some nano robots or some other things, to actually track all the destructive influence we have on biosphere? And let's say, because I like that childhood concept of carbon credits. I truly love that beautiful market, but it's not just, it's not all we do for all type of destructions we do with that land and with that world. What is it possible from your perspective, maybe in 10 years or 20 years, to create that type of solution to, let's say, to actually track all of that, to track everything?
Absolutely, yeah. And some of these things are in sort of research labs right now, where you can actually have these very large scale distributed, very small energy efficient sensors that are tracking many of these things in the field. So sort of the concept is broadly known as smart dust, right? So you have these very, very tiny sensors that individually each of them is doing, sensing one particular aspect of the ecosystem. They're all sort of a massive IoT network of these distributed devices. And that allows us to track, lots and lots of good and bad things that are happening in the ecosystem. And yeah, I think, that is certainly coming. We are ourselves sort of, keeping an eye on those things. And we think our systems will be directly compatible with that. Robots could be one of the ways of like, probing these smart dust sensors. So the robot goes through and sort of pings the smart dust sensors that are distributed and says, okay, what have you recorded since the last time I came by, right? And then all of that is passed to sort of centralized system that models and predicts what's going to happen. And it's a feedback, right? So based on what it's seeing, you can then deploy different types of robots on that piece of land and say, hey, we need this kind of stuff done. We need more fertilization. We need to hold back fertilizers. There's, increased risk of insects in this part of the farm. We need to send out some insect control mechanisms, all kinds of stuff. So yeah, absolutely.
Very interesting. Okay, the question is, let's say, what role can Sandboxes like our project, like Elmas land, because we're not big. We have, let's say, currently just 3 eco villages. We are building 3 eco villages, so maybe by the end of the year we will have 5 eco villages. What kind of sandboxes like ours, let's say, to do in, let's say, it's in a strategy you just, let's say, highlighted? What role of our sandbox could be important from your perspective for that big play?
Yeah, no, these kinds of sandboxes are fantastic. These, they're critical, in fact, to evolution of emerging technologies, where there's the right type of people with the right mission and mindset that are congregating around these ideas, and then working together in a collaborative way to test out some of these emerging concepts without being, because if we take these same technologies to the farmers have much more important day-to-day problems to solve, right?
Yes.
They don't have time to futz around with sort of, half-baked future technical concepts. But people like us, groups like us can work together and figure out, okay, this is what we want the world to look like in 10 years. What do we need to do right now that moves it forward, right? So I think, yeah, we'd love to be a part of the eco villages and figure out, like, okay, yes, in order to have this kind of a system that can be replicated, not just from 3 to 5, but maybe 5 million, what do we need to have from a technology perspective that will make that easy for people to scale up?
Thank you so much. Actually, your solution potentially will help us protect not just the soil, not just the land, but protect also our values, because you do realize that we have very special approach towards the biosphere itself. So we could, let's say, be very advanced with opportunities to use the data coming from your robots and creating that some sort of digitalized culture, because what's the decentralized autonomous organization is all about, what's our project is all about, the ability to create the values digitalized, the values, let's say, values as a program.
Exactly. Yep. It's enshrined in the architecture of the DAO. Yeah.
Yes, and that's our approach. Thank you so much. And the last question will be, what are the most exciting events to expect from EarthSense, from your unique startup in the coming months? What should be on our radar?
Lots of cool stuff happening. One of the big things that we're doing this season, so the North American agricultural season is just starting up. So we'll be, hard at work in the fields, showing various next generation capabilities of our robots, including precision fertilizer application, including large scale cover crop planting, including weed control with these autonomous robots. So we'll be scaling that up, and we'll be sharing all of that fantastic news. And then, of course, there's, one of the big things that's not directly visible is doing these kinds of compute in a fully disconnected, in a distributed manner. So the distributed, swarm intelligence is something that enables all of these technology, enables all of these performances.
But by the way, it's a quick question. Are you using some sort of LoRa? Are you using some LoRa, let's say, network? Yes?
All of the above. Yeah. So we use Wi-Fi, Bluetooth, LoRa, depending on what we're transferring and how far we're transferring, the robots pick the right communication modality.
Wow. That's,
and then we're building the base station for the robots to have
mesh.
Most of the places to have like connectivity with each other and connectivity with satellite communication network too.
Wow, it's really one of the most beautiful projects I have ever seen in that sphere. So how to follow your project? Do you have let's say Twitter account we should follow or something like that? Is it Twitter?
Yep, we are on Twitter at EarthSense_INC.
Okay.
And then
it'll be down below.
Yeah, and then we're earthsense.co on that's our website. We're keeping a lot of the things in stealth, really. So our website currently just says, hey, we do large scale cover crop planting, but there's lots of cool stuff happening in the background. But we'll be talking more publicly about things as we make progress. We believe in showing rather than saying. So once we are confident that we've solved this problem, then we start talking about it.
Yes. Sometimes people have very beautiful stories, but by the end of the day, the winners is those who just making things
we actually have to do get things done, and these are hard technical problems to solve. So takes a while to get it fine-tuned and get it working to our satisfaction, to where we're proud to talk about it.
Thank you so much. Thank you for that IMA session. Thank you for opportunity to talk and discuss all important questions with you, and for the honor of working together, let's say in our sandbox to enrich the both of our projects. It was a real pleasure to discuss all of that with you.
Fantastic. Yeah, thank you very much.